The new cutting-edge AI assistant is revolutionizing technology by enabling developers to push the limits of AI and realize the full potential of their creations. So, what potential benefits do you see for SWE Agent in terms of improved software engineering and teamwork? As you are aware, automation plays a significant role in the ever-evolving field of software engineering, improving productivity, efficiency, and error reduction. Suddenly comes SWE Agent, a revolutionary creation of researchers at Princeton University that could change the game entirely. Using massive language models, this cutting-edge technology outperforms others on the SWE bench assessment set. Suppose this to be the case, a technological miracle. SWE Agent turns LLMs into real software engineering agents that effortlessly resolve issues in GitHub projects in real time. Programmers are able to effortlessly shift between software engineering jobs and LLMs because of the Agent-Computer Interface ACI. SWE Agent's LM-centric instructions and feedback forms enable code file navigation, editing, and execution by LLMs more effectively than before. This SWE Agent is a game changer, not just another tool in the software engineering toolbox. With an astounding 12.29% issue resolution rate, it exceeds Devin, its predecessor. Devin performed admirably, achieving 13.84%, but only on 25% of the test set. SWE Agent, which offers cutting-edge performance on the whole range of difficulties present in actual GitHub repositories, comes into play in this situation. However, data only tells a portion of the tale. Imagine that there is a bug that appears in the PyPython library. The SWE Agent jumps in, replicates the bug, and proceeds to take it apart piece by piece. It's like watching a real-time master detective solve a case only with lines of code in place of clues. What's the best thing then? This isn't just some abstract idea. On April 10th, researchers will release a study that will reveal the inner workings of this miracle of artificial intelligence. One thing is certain. As expectations rise, SWE Agent is changing software engineering norms one bug patch at a time, not just increasing productivity. This team's efficiency and quickness in creating such a powerful instrument are truly remarkable. It is evident that these models are performing equally well with a mere 1% gap between them. Even more exciting is the possibility that next versions will push the envelope even beyond, particularly in light of upcoming developments like GPT-5. When compared to Devin's standard, there is a noticeable improvement. This open-source gem has caught up to its closed-source equivalents, while other systems have found it difficult to keep up. It's evidence of the flexibility and agility of open-source models, demonstrating their potential to outperform their closed-source equivalents in addition to keeping up. Their similar foundation and base-level GPT-4 or possibly Claude Opus, with sophisticated planning and coding skills baked right in, may be a major contributing reason to this catch-up game. It's anyone's guess where these models will lead us next as the competition for invention intensifies. Coming to the next, which addresses the inner workings of this agent for software engineering and illuminates its distinct approach. The agent operates within a dedicated terminal, allowing it to navigate, modify, and test files with ease while maintaining structural integrity. Its exceptional performance is largely due to its specially designed interface. So, how does the iterative methodology of the software agent work? The presentation clearly illustrates how it uses a methodical approach to observe, analyze, and perform activities as part of its cognitive process. Every step from identifying coding inconsistencies to formulating solutions is carefully thought out. Its iterative methodology, which alternates continuously between thought, action, and observation like a never-ending feedback loop, is what makes it so fascinating. Its incredible foresight suggests that this open-source miracle may be used for long-term planning or iterative optimization. It provides an early look into automation and productivity in the future and is a monument to the strength of AI-driven software engineering. One fascinating feature that emerges is a new design expressly intended for improved interaction with language models. It is discovered that merely attaching an LM to a typical bash terminal produces less than ideal results. The pivotal realization? Just as humans require user-friendly interfaces, LMs require carefully designed agent-computer interactions. This finding emphasizes how crucial a smooth interface is to maximizing the effectiveness of the LM. The new architecture, cleverly developed to meet LM requirements, enables a mutually beneficial interaction between the interface and the model. Through the provision of clear instructions and predictive feedback, it enables LMs to do jobs with unmatched speed and efficiency. The symbiotic workflow, a feedback loop where the LM-friendly environment feeds into the agent, which organizes operations and delivers real-time feedback, is effectively presented. This combination maximizes the performance potential of the LM while simultaneously preventing faults. With the introduction of this new design, a change in perspective occurs, enabling the software engineering agent to operate at previously unheard-of levels of efficacy. Unmistakably, it has impacted performance and brought in a new era of AI-driven software development. Surprisingly, the researchers found that restricting the SWE agent's file access, letting it see only 100 lines at a time, produced better outcomes than enabling it to examine longer sections or the complete file. At first look, this strategic limitation could seem illogical. It stands to reason that giving the agent more data would improve its functionality. The team's results, however, imply differently. The agent can more efficiently focus its computing resources by limiting its scope to smaller segments, which improves job planning and execution. When the complex nature of the task at hand is taken into account, the reasoning behind this technique becomes more evident. The agent can process and interpret the data more quickly with a smaller subset of information, which lowers the possibility of confusion or mistakes. Furthermore, this method emphasizes how crucial sound agent computer design is, especially when utilizing sophisticated AI models like GPT-4. In the future, it presents interesting queries on the ideal settings for AI-powered software engineering agents. Will there be a set amount of lines that are optimal for efficiency? The software engineering agent's amazing adaptability is then highlighted with a focus on how simple it is to configure and how it may be expanded for further study. The software engineering agent provides an ideal environment for experimentation and cooperation because it is open source. Comparing this openness to closed-source competitors such as Devon highlights how important it is. Even with the small performance difference between the benchmarks, the open-source software engineering agent has room to grow and expand quickly. The agent exemplifies innovation in the sector with its simply adjustable nature, cost-effective operation, and efficient performance. With the anticipation of its forthcoming paper publication and ongoing development, it is evident that this agent marks a substantial advancement in the pursuit of more efficient and approachable AI solutions in the field of software engineering. So guys, how may the broad use of this open-source software engineering agent transform our approach to solving software development problems? To be up to current on the newest happenings, make sure to follow, like, and subscribe to the community and keep an eye out for updates.